In the last lesson, we talked about circumcenter and incenter, so the points of concurrency of your perpendicular bisectors and your angle bisectors. We've actually got two more points of concurrency we're going to talk about in our triangle. So today we're going to look at what's called the centroid and the orthocenter. So before we can talk about the centroid, we have to define the segment called the median. So let's go ahead and write down the definition of median. Okay, so a median is a segment whose endpoint, one endpoint is the vertex of a triangle and the other endpoint is the midpoint. And remember, you can tell if something is the midpoint by looking for these congruent marks, right? So the side is being cut in half. So what I've just done here in green on this triangle is a median. So again, a segment whose endpoints are a vertex and a midpoint of the opposite side. Okay, so then the centroid, of course, is going to now be our point of concurrency of the three medians. So you can take each vertex and connect it to the midpoint of the opposite side to create what we call the centroid. So let's go ahead and write that down next. All right, so now we have, again, the point of concurrency of the medians of a triangle. So you've got three medians that I've done here in green, blue, and red. And then this point where they all intersect, that point of concurrency, this is what we call the centroid. All right. So now that we know what a centroid is, there's an important thing to note here because it does show up in I think some word problems here or there, and it's also kind of just nice to know. The centroid is also what we call the center of gravity of the triangle. So it's the point where a triangle would actually balance. So let's write that note down as well. Again, just kind of interesting, and if I'm asking you to find the center of gravity, you know you're looking for the centroid. All right, so again, just look for that in vocabulary in the word problem. If I'm asking for, again, where will the triangular region balance, or where will the triangle balance, find that centroid, okay? So connected to centroid is what we call the centroid theorem. So of course, again, this point of concurrency gives us more information about segments, about things going on in this triangle. So the centroid theorem says that the centroid of a triangle is located 2/3 of the distance away from each vertex to the midpoint of the opposite side. So we're going to write that down. I think this actually makes more sense when you look at the equation in the relationship. All right, so again, that's your centroid theorem. Remember, feel free to pause if you need to write this down, but I'm just going to keep on talking. Okay, so if you take a look at this diagram, we know here that P is the centroid because notice it goes from a vertex to midpoint, right? So that makes it a centroid. So we know P is the centroid of triangle ABC. Now, what does this tell us based on the centroid theorem? So why don't we look at one median at a time? So let's just look at this median AY, all right? So what this theorem says is that the distance from the vertex to the midpoint, the distance from the vertex to the centroid is 2/3 of the distance from the vertex to the midpoint. So basically, the distance AP is going to equal 2/3 of the whole median, AY. And again, this is your centroid theorem. So again, each vertex has its own median, so we can also say CP is equal to 2/3 of CX. And what do you think that last relationship for the median BZ is going to be? Well, we would be able to say that BP, right, vertex to centroid, is equal to 2/3 of BZ. Now, related to that, you can also say PZ is 1/3 of BZ, right? So use that segment addition postulate idea, right? 2/3 and 1/3 to make one whole. And sometimes that's handy in a problem, okay? Let's take a look at the first example. Example 1, in triangle LMN, RL is 21, SQ is 4, find each length. Now remember, when we're dealing with points of concurrency, it's really important for you to identify what do we have, incenter, circumcenter, centroid, and what we're going to look at later, orthocenter, because that's going to help you figure out the relationship you're using. So here again, we're looking for two things for centroid, right? See that the endpoint is a vertex. Oops, that's my dog, don't worry about that. And the other endpoint here is the midpoint. When you have a vertex and a midpoint, we know that S is the centroid. right? So now we know we have a centroid, which means we can say a bunch of things. I could say, NS is 2/3 of NQ, R, excuse me, not R. LS is 2/3 of LR, right? MS is 2/3 of MP, right? This is all what we know from the idea that S is the centroid. Now, going back to the problem, I want to say, well, what is the most important part here? And oops, man, I have typos all over the place. We have two parts to this problem. Here's part A. We're going to find LS, okay? So if I know RL is 21 and SQ is 4, how do I find LS? Well, the entire thing L to R is 21, and I know that LS is 2/3 of LR, so all I'm going to do is plug in that value, 21, in for LR, right? And then 2/3 times 21 is going to get me 14 units. Okay? Part B, which forgot to type onto this. Let's also find NQ. Now, NQ is the entire length of that median, so this is where it could get a little tricky. All right? I know SQ here is 4. So if SQ is 4, right, how's that going to help me find NQ? We can do a couple of things. If I can figure out what NS is, I can figure out NQ, right? Or, remember, if NS is 2/3 of NQ, then SQ should be 1/3 of NQ, right? Because 2/3 plus 1/3 equals 1, right? That's just using some logic. So then if I know SQ is 4, I can solve for NQ by multiplying both sides by 3, and NQ should equal 12 units. Right? I think that's the more straightforward way, but of course you could use the centroid theorem to figure out NS as well, or use the segment addition theorem to figure that out as well, but I think this one's a little more straightforward. But if that's confusing, feel free to let me know in class and I'll show you the alternative. Okay? Don't forget to come back to class and ask questions if you have questions on any of these things. All right. Finally, let's bring this to the coordinate plane for centroid before I move on to orthocenter. Take a look at example 2. A sculptor is shaping a triangular piece of iron that will balance on the point of a cone. Notice that keyword balance. Okay, we've got a triangular piece that's going to balance. Those are two things we want to look at together. Okay, what coordinate will the triangular region balance? So if I imagine, making a cone, balancing a triangle on top of it, where would I put it on the coordinate plane? The point of the cone, right? So remember, if we're looking for where the triangle is going to balance, this is a key phrase telling us, let's find the centroid. So what we want to do is we want to figure out the point of intersection of your medians, right? So go from your vertex to the midpoint, right? Go from the vertex to the midpoint to get your median. So I'm going to tell you two ways to do this, and you guys can really think about what's easiest for you. I know I have a personal preference, but you can look at both and decide for yourself. So here's method number 1. All right. What we're going to do is we are going to draw 2 medians using 2 midpoints, right? So, for example, let's call this triangle ABC, just so you know which points I'm talking about. Let's find the midpoint of AB. Right? Use your midpoint formula. x1 plus x2 over 2, y1 plus y2 over 2, and find that midpoint. And I'm going to find the midpoint of AB and BC. So there's my midpoint work, right? Finding the midpoint of AB, which is 8 and 6.5, the midpoint of BC, which is 9 and 4.5, and you can see on the graph I sketched them in. So to find the centroid, all I have to do now is actually connect the midpoint to the opposite, oops, that's not what I meant to do, Connect the midpoint to the opposite vertex. So take that midpoint and connect it to the vertex. So there's my first median. All right. And then here is my second median. And that point of intersection is going to be that centroid we're looking for, right? So right here, this is the centroid. Right, so my centroid is going to be at the point 8, 5. And there's my answer. All right, so that is one way to find the centroid. The second way you can do this is imagine balancing, right? What do we mean when we balance, right? You can think about it as an average, right? Balancing scales, things like that. So what you're going to do is you're going to basically average the points. I'm going to put that in quotes because that's what I'm using to describe the process. So we're going to average the vertices, which means all you're going to do is do x1 plus x2 plus x3, so the three different x values, divided by 3, right? y1 plus y2 plus y3, the three different y values of the vertices, and divide it by 3. And let's see if we get the same thing, okay? So I'm going to do the x for A, the x for B, the x for C, right? The y for A, the y for B, and the y for C. Oops. And divide it by 3. And that's going to give me 24 over 3 and 15 over 3, which reduces back down to that same thing. So two different methods. Personally, I prefer method number 2, but visual people might prefer method number 1. Regardless of what you do, show me that work. That is a centroid. Okay? Cool. So that is your centroid and centroid theorem. 3 points of concurrency down, 1 left to go. So our final point of concurrency is called the orthocenter. And remember again, there's all these lines going on in your triangle, so you really want to make sure you're identifying what are the intersections of, right? Perpendicular bisectors, angle bisectors, medians, and now what we're going to talk about, altitudes. All right. The altitude is what we normally think about as height. So it's the perpendicular distance from a vertex to the opposite side, and it could be inside on or outside the triangle. So that's something to be aware of. All right, so again, pause if you need to write this all down, but a perpendicular segment from a vertex to the line containing the opposite side is what is known as the altitude. And again, it can be inside when we've got an acute triangle, outside with an obtuse triangle, or on when it's a right triangle, the triangle itself. And that's what we're thinking about when you've done area of a triangle, when you look for those heights. Remember, it could be inside, outside, or on the triangle, all depending on what type of triangle you have. So for example, in this first diagram, each of these right here that I'm highlighting in green, this is an altitude, right? These are all altitudes because it intersects at the right angle. So notice it doesn't have to be the midpoint. There's no midpoint going on here. Midpoint is only for medians. Okay? So each of these are what we call an altitude. And notice, again, with this obtuse triangle, your altitude could be in the exterior, right? So outside here, this is an altitude, right? Inside is an altitude, but outside here, this is also an altitude. And you can extend the altitude. It doesn't have to be, stopping on each side. And notice how you can also extend the side out, the dotted line, to create that right angle. And that's perfectly fine. So these are all altitudes, right? And of course, the orthocenter is going to be the point of concurrency of your altitudes. Let's go ahead and jot all that down. All right. Now, one final example, and this is finding the orthocenter of a triangle on the coordinate plane. And this, scroll down here, is just one set process you're going to need to know, okay? And again, as long as you practice it with this set of steps, you'll be fine. Just try to remember how to do this. Let's first start by graphing your triangle. All right, so there's your triangle, and next we want to think about a game plan. So what we're doing is we need to find the point of concurrency of the altitudes. Really, if you just find 2, we can get the point of intersection, what we're looking for. So let's find two altitudes and let's find their equations so we can do a system of equations to find that point of intersection. All right, so again, that's our game plan for any of these orthocenter problems. Find two altitudes, get your two equations, solve your system. Now, one thing to note, it's super easy to find the altitude when you've got a horizontal or vertical line. So let's find that first. Take a look at the vertical side, yx, and it's super simple to find the altitude from yx to the opposite vertex because, remember, anything perpendicular to a vertical line will be horizontal, so we can just use the grid lines here. So I can sketch in the altitude from z to yx. And now all we have to do is write the equation of that line. And remember, the equation of any horizontal line is just y equals some number. So the altitude from z to yx is just the equation y equals 1 because it's that flat horizontal line. Remember, if it's vertical, it's going to be x equals, horizontal is y equals. The trickier part here is to now find the altitude from any of the other vertices because yz and xz are both slanted. We've got to do a little extra work. So it doesn't matter which side you pick. I'm going to go ahead and go from y to the opposite side, xz. All right. So what we have to do is we basically have to write the equation of the line that is perpendicular to yz and passes through y. And remember, y is 3, 6. All right, so just start working this out. We want to find the perpendicular slope, and we want to find the equation of the line. So let me scroll down so I've got a little more room. There we go. All right, so now let's find the equation that's perpendicular to, sorry, not yz, my bad. This should say xz, and goes through y. So let's fix that actually. So that should say xz, since we're going from y to xz, and go from there. All right, so we're going to find the original slope first. So you can do whatever you'd want. You can either count rise over run like I'm going to do here, or you can figure out slope using slope formula. It's up to you. So I'm going to find the slope of that highlighted green line. So I'm going to count up 3 over 4 to get a positive 3 over 4 as my slope. Remember, I'm dealing with perpendicular, so I want to make the perpendicular slope. So the opposite reciprocal will be negative 4 over 3. Okay? Then I know the point I need to pass through is y. So x1, y1 is y, right, 3, 6. Now let's use point slope form. Y minus 6 is equal to negative 4 thirds times x minus 3. Okay? That now gives us our two equations. Y minus 6 equals negative 4 thirds times x minus 3. And this y equals 1 right here. And we can use that to find the point of intersection. So here's my system. I need to solve for x and y when y is equal to 1 and y minus 6 is equal to negative 4 over 3 times x minus 3. Now, if it's helpful, you can solve for y and get y by itself if you'd like, or you can just deal with your point slope form. It's up to you. Since we have the y value, it's actually super easy to just take this lovely number 1 that we already have and plug it in for y down here. One note to consider, however, if you don't have a vertical side or a horizontal side, you're going to have to do what we just did in blue twice. And then I would suggest you actually solve for y and use point slope intercept form to solve your system using substitution. All right, but if we get to that type of problem in class, definitely let me know or on your homework and we can work that out together. But let's go ahead and finish this off because I know this video is getting pretty long. So I'm going to plug in 1 for y and go through and do my algebra to solve for x. Right, and you can distribute here if you'd like. Remember, it is perfectly okay for your answer to end up being a fraction. All right, So I'm going to multiply both sides by the reciprocal, so multiplying by negative 3 over 4 is going to get me negative 27 over 4. Okay, so that means my final solution, my orthocenter, is going to be the point x comma y, where x is negative 27 over 4, and y is 1. And that is it. So orthocenter, again, kind of long in terms of the process, but it's always going to be the same thing. So the more you practice it, the better it's going to get. Definitely come back to class with questions, and I'll see you in class.